Hello, everybody. We are going to continue on functions. Now, a main question that we will start with today is that can a map be a function? So, you might see that two groups, in the two groups that we have, the inputs and the outputs, these inputs can be mapped to outputs in many ways. Now, can all mapping be a function? That is what we are going to find out in today's lesson. So here, if you see in the first example here, the input is words and the output is the reverse words, right? And that's why it's written in this notation: f of words is equals to reverse words. The second one is where we are having a shape as an input, and the output is a shape with one side fewer. The third one is the input is a number and the output is a one added to the number that we are keeping in the input. So let's try to find out like that when can we call a mapping a function. Now, we'll be focusing on the relationship between the inputs and the outputs. Uh, so, let's consider this one over here. Now, you see here that the input 4 is giving you two different outputs, right? 8 and 12. Now, can we use function notation to represent this? How can we do this? Like, is there any way in which we can say that, okay, if I put the number 4 in the input, the output is coming as, so if I take 2 times number, the output should be 8. If I take 3 times the number as the rule for the function, the output should be 12 here in this particular problem. So I can't take a one single function which is giving me two outputs, and hence it isn't a function, because you can see here that the output 8 and 12 will come for two different rules, and hence this mapping isn't a function because we cannot come up with a common rule which will give you two outputs for a single input. Now, so every function is a map, right? But it's not the other way around. Like every map is not a function. Now, how can we tell from a diagram that a map is not a function? So, if you see in this table, just like an input is giving you two different outputs, right? So, there are two options here. Uh, the first one says more than one arrow comes from a single input. So as you can see over here, right, from a single input, there are more than one arrows, there are like two arrows, or more than one arrow goes to a single input, goes to a single output. So that is possible. Two different inputs can have the same output. That is still possible for a mapping to be a function. But if a single input is giving you two different outputs, that's not possible. So this is not a function. So whenever you see that from a single input there are two arrows coming out, it means it is a mapping, but it's not a function. Now here, yeah, you can see that this one is a function where we have two inputs, 8 and 12, and they're giving you the same output. So this is still a function because two different inputs are giving you a same output, not the same output giving you two different, not the same input giving you two different outputs. Now, we have a question here, and it asks us. We have three different scenarios here, and they're asking select the map which is not a function. Okay, so in the first case, I see that all three of them have unique outputs. Like for each input, we have an output. So there's for each of the inputs, we have just one arrow pointing towards the output. In the second one over here, I see the same, right? In the third one, I see that the input 3 is giving me two different outputs. For the input 3, I'm getting 3 as an output and 4 as an output as well. So this mapping is not a function, as the single input is giving me two different outputs. And that is correct.